many points do you quiz today?
5. 5 homework points.
Oh yeah, to answer your question.
Only a little delay.
Special.
Yes.
Oh. Do you guys get to school at different times?
No.
Oh. You just didn't walk with you?
So no.
Did you just run the bus?
Olivia, after we do this short little quiz, you need to go to your counselor. Lena, I heard that you met Mr. Young this summer.
I did. Did he tell you about it?
Yeah, he texted me.
Yeah.
Probably the same day.
No.
We used to be pretty good friends, but they moved off years ago. Him and his wife moved off, so we still text, but I've seen him like one time in the last 7 years.
Yeah. He was nice. He led the engineering section at AGS.
He's a really smart guy.
He's really smart.
Yeah.
So was his wife. It was a little daunting. I was like, oh.
Yeah. Oh, you met his wife too?
Yeah, she did a presentation for us. Interesting experience.
Well, he said good things about y'all. That y'all were a much better group than the year before.
Well, I'll take that. I think last year was the first year they did it, so they really didn't have like a
Yeah.
set plan. So I think they just. Oh, Thomas, I don't know if you know who Thomas draws this class to be a TA for
Okay, Thomas.
Jude.
I'm not paying attention.
Okay. Thank you for letting me know.
Yeah.
So who's better, A day or B day?
At what?
Like making you happy? No. And what? It's just a general question.
This year probably B day, because I only have to teach 2 classes on B days, and I have to teach 3 classes on A day.
But I mean,
Okay,
It does
so
count for everybody.
that's a positive though, right?
No.
So if I was in B day, would you be like, oh, A is better? There's only 2 classes.
yes,
I'm your favorite student though, right?
I don't have favorite students.
Okay, well, I'm your least hated, right? Least disliked.
I don't hate any students either.
My B day? It was just AP Lit.
Only?
Yep. But how did you get Lit?
Yeah. 9 for 6 on B.
Okay, back. How do you combine this up like?
Did you know that, Mr. Townsend? Sam's a pescatarian.
Okay.
Little cool trick he has. We're friends.
Why are you in everybody's business?
Huh?
Why are you in everybody's business?
What do you mean? We're friends.
Okay.
Mikasa Sukasa.
Oh man, that's definitely.
That should be the bell. I guess they don't have a bell at the tardy period, so.
That's the end of the life. Oh no, that's my house.
we need to get started. Okay, we're going to start off with our short quiz that I warned you about. So it shouldn't be any surprises. It's only 5 points, which again, it's going to mean almost nothing at the end of the semester, but for right now, it's going to be your only grade. So if you would, this is no calculator. Go ahead and start it and get it. And then I'm going to ask that you turn in 2 things as you finish. I want your quiz. They're 1 point each, no partial credit. And I will ask for the getting to know you page that I didn't collect last time. You can throw both of those in this basket as you finish. Take a couple minutes. But again, these are pretty much you know or you don't. After a couple, I will cut you off. Turn it over. So again, as you finish, make sure your name's on it, and please find your Get to Know You handout and just turn them both into the basket up here. And if you're not finished in a couple minutes, I will tell you to move on anyway. No calculator. Cute. you. Take that pass with you in case you get stopped in the hallway. The one that's hanging there. Okay, Christian. What am I gonna say?
Oh.
Sorry?
Let me put these together.
No, it's fine. I'll sort them out.
Thank
You
you.
just throw them
I
in there.
meant to turn this in with my.
Yep, just throw it in there. Okay, anybody still working? Okay, also, I need you to do a quick little survey. So on number 4 up there, there is a Google form, and I think that's case sensitive. I told it to make a short link, but that's as short as it would get. That just has to do with, it's for us, it's not going to me, but it's just information about calculators. If you have your own calculator, if you're hoping to use a calculator in class, if we were able to get some calculators for you to like check out like a textbook, would you be interested in that? So, Ms. Cross, who's the other calculus teacher, is collecting that and passing that on to Mr. Reef, who is the AP department head, and seeing if there's something that he can do to help us out there. So I need you to fill that out. Even if you don't need a calculator, yeah.
There's no third period option. Which option do you choose?
What does she want? Is there a third period BC option maybe? There's just no third period option?
No,
Can you just skip that question or is it required?
it's required.
Then let's wait. We'll just do the survey next class.
Okay.
The sooner they get it, the information, the better, but like I said, I didn't make that survey, so I didn't realize. So don't worry about that. I'll put that on the agenda next time. All right, so last class we did some first day type stuff. We did some reviewing unit circle and log properties, but the big calculus thing was limits of graphs. And I don't know, everything is kind of a trade-off in this class. To me, that's one of the easier things we do. So the trade-off is we spend almost no time on it. The hardest things that we do all year long, we'll tend to spend 2 or 3 days on. So try to balance it out for you in the end. But that one is a one-day thing. So I think some of the handouts you picked up should be numbered. Did I have this one numbered as number 6? Did I number it before I copied the page? Okay. As I said, I'll try to number them before I run off the copies this year, so you'll have to do that a little bit less. But as we mentioned, the first day of class, once you have a binder, 6 just needs to go behind number 5, and then that's it. Okay, today we're going to do the exact same thing we did last time, except instead of given a graph, and you're looking at a graph to determine the limit, we're going to try to determine the limit if we have the function. This is called analytically. Now, sometimes these questions can be about 5-second questions, and sometimes these can be a little bit of a pain. There's something called indeterminate form, where we have to do a bunch of different algebra type of tricks. So, the first thing that you should always do in this, so notice this looks a tiny bit different than what we did last class, because instead of being x squared, it might have said f of x or g of x or h of x, and you looked at the graph that matched that. But always, 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 when you do it this way, you should try this thing called direct substitution. Direct substitution, whether it's an easy question or a hard question, you'll have to do direct substitution. So we're just going to take this 3, we're going to plug it in everywhere there's an x, and if we get a real number, like 9, we can assume that that is our answer to that question. Plug it in, if you get a real number, that is your answer. So what's really happening, and you don't want to always do this, but you should have an idea of what x squared looks like. As x approaches 3, it approaches a y value of 9 from the left and from the right. But without that graph being made for you, that ends up being more work. So this is where we're doing basically the same thing. All right, if we try direct substitution on number 2, we get 4 divided by 0. And what happens when you take a number other than 4 and divide it by 0? Okay, and how would we say undefined for limits? Does not exist. Can't divide by 0. Okay, we can try direct substitution on the third one, but when you do that, you're going to get 0 over 0. And then this ends up being the first real problem we have to tackle in calculus. So if we have 0 over any other number, it's going to be 0. If we have a number, any other number other than 0 over 0, we get does not exist. That's what we saw in question 2. But 0 over 0 can be anything. And these are the ones that take a little bit of work. They're a little bit of a pain. So what we have to do is we have to, well, you should make a habit of showing that it goes to 0 over 0. That's important in FRQs, so just a good habit to be in. But we have to change the way this question looks without changing its size. So this stuff, we have to make it look different. And there's 10 different ways that you could do that algebraically. This one's the most common. So what could we do with this numerator? How could we make it look different? Okay, you can factor it. It's the difference of 2 squares. And this is the most common way to deal with 0 over 0. In fact, I would bet money that one of your AP questions is going to be this skill at the end of the year. You're going to get 0 over 0. You're going to factor it like this. What happens after you factor it? Okay, something has to cancel, and the second that something cancels, you can try direct substitution into what's left over. So plug it into what's left over, and then if you still have 0 over 0, you have to do more work, but if you end up with the real number, we can assume that that would be the answer. So we make it look different so that we can simplify it, and then we go back to direct substitution. Problem is, factoring is not the only way to do this. There's lots of different algebra tricks that you can do. So if you know what the graph looks like, you're welcome to visualize it. Otherwise, we kind of have to do these things. So even though I just said the steps, it's super important that you have those first few steps outlined. So if you saw this on the test, which I would suspect you probably will see one, if not more, what's the very first thing you should do? Direct substitution. Calculus can be hard. We do hard stuff, but there's no reason to not know right away that you do direct substitution. Unfortunately, plugging it in, you get 0 over 0. So this is the one that we have to make this stuff look different so we can simplify it. Okay, and like the last question, what were you sharing about that, Christian?
Vector,
Okay, so again,
expand that.
difference of two squares. And usually, if that's really what you're supposed to do, something needs to cancel, so you kind of know if you're on the right track or not. And then try direct substitution again. So we hope the first direct substitution just gives us our answer, like question 1 at the top. But if it gives us 0 over 0, we make this look different, get something to cancel, and then do direct substitution again. And then if you end up with a real number, like 10, you can assume that that is correct. Now, what if you had a calculator? Could you do this same question with the calculator? How would you do it with the calculator?
Plug it into the graph.
Plug what into the graph?
X squared minus 25 over X minus Y.
Right. So, I don't think we would put this on the calculator portion of the test because I don't think your AP test would. But in theory, you could graph this, and then you could do what we did last time. You could look at the y value that it approaches from the left of 5, the y value it approaches from the right of 5, and it will be approaching 10 from both sides. So, we're just doing it without the graph. Okay, the back page of this, I did not make this, but it does kind of give you a visual of what I said on that page with a few more examples. You start off with direct substitution. If you get a number like this, you're done. If you get a number over 0, it does not exist. And if you get 0 over 0, you've got to do more work. So sometimes that's factoring, sometimes that's an algebra trick called conjugates, sometimes it's going to be trig identities, but basically you need to make it look different so that something can cancel, and then you can see it says go all the way back up and then do direct substitution again. So I feel like that visual kind of outlines the process, so I think it's worth printing out for you. But you don't have to do anything on that other than kind of read through it. Okay, let's look at one of these together, and then I am going to give you a few minutes to try a few of these. Some of these you need to do stuff like on the front page, like we did on the front page, but this also has some piecewise functions, so let's look at least, I don't know, the first 2. This wants to know what could be a reasonable limit for as x approaches 2 of this, given this table. So, without even looking at this question, think about what we talked about last time. What had to be true for a limit to exist? Okay, I'm sorry, one more time. Okay, so from the left and the right, it has to be approaching the same y value. So if I care about -2, then from the left, it looks like it's approaching what? Okay, and then from the right, it looks like it's approaching, and if it's approaching the same thing on the right and the left, that's your answer. If they're approaching something different, it does not exist. Same thing we did last time, but this is just table format instead of a graph. Okay, one more for a piecewise function. If I want to know, okay, let's skip that one. This may not have printed off great. Skip to question 3. This should be, actually, let's just do it as 3. As x approaches 3. That'll be good. So for this limit to exist, it has to approach the same thing from the left and the right. Well, which one of these two should I plug in if I'm interested in the limit as x approaches 3 from the left? I'm sorry?
Are we asking this function?
Yeah, which one of these should you plug it into?
The first one, expression.
Okay, and how do you know that? Right, when x is less than 3, which is when you're approaching from the left, when x is slightly smaller than 3. So for that one, you would plug it in here and get 9 minus 1. And then sometimes, not always, you need to pay attention to the numbers. If I cared about approaching from the right, I would plug it into the bottom, because this is when x is greater than 3, and from the right is when it's bigger. I plug it in there, and I get 6 plus 1, which is 7. So, what's the final answer to number 3? The limit from the left is 8, the limit from the right is 7, so the limit does not exist. It's got to be the same from the left and the right. So, it's not that piecewise functions are like the most important thing, but they're usually the ones that y'all need the most practice with, which is why there's a lot of these on here. So what I want to do is give you a couple minutes to work and try some of them on this page and see how it goes. And then that'll give me just a second to get the rest of these quizzes put in. I can't pass these back to you today because I've got classes taking it tomorrow, but I do want to get the grades in at least. And then we will regroup here in a few minutes. let's regroup for just a second. So give a little bit of feedback here. So on question 1, did anybody get, looks like the answer to question 1 should be 0. Is that what y'all got? Okay, so here's where you've got to be paying attention. You can't, if I could simplify how to approach this question for you, then I would. I didn't say on this question, just plug it into both and see if they're the same. It depends on this. On this last question, we needed to know as x approached 3. So I needed to know what's happening to the left of 3 and to the right of 3. But this one wants to know as x approaches -5. So which one of these two should you be plugging it into? Only the top. Because this guy is way off from -5. This is just a complete distractor in number 1. You can't just oversimplify and say plug it into both. Pay attention to what you're doing. So if you plug this in, you got this, and that comes out to be 0. This is how unit circle kind of sneaks into what we're doing. The y value at -5 pi would be 0. So make corrections there if you need to. Okay, number 4. Again, I know some of this doesn't, did this plus print off on your page or not? We can work it either way. Okay. I'm hearing no, so let's pretend like it's not there. So this one you should have gotten, I believe, does not exist. Is that what you got? Okay, somebody who got does not exist, can you tell us what you did? And I will do the writing, just the overall process.
So from approaching from the left would be the first one.
Okay, so you plugged it in here and got,
Maybe 1 there.
okay, that sounds right.
And then the bottom one approaching from the right, you get 1/16.
Very good. You get 2 to the -1/4, which is 1/16. And if these aren't the same, then the limit does not exist. Unless you work it from the left or the right. If it had just said the left, this would be your answer. If it said just from the right, this would be your answer, but it didn't print off for y'all, so it sounded like you should have worked it as both. These two have to be the same. Okay, so now I've given you a little bit more help. Sometimes, like this first question, you should only plug it into one of them. It depends on what the piecewise function's saying. Sometimes you need to plug it into both. If it's not the same from the left and the right, then the limit doesn't exist unless that's what it's asking for. So go ahead and keep on going on this page for a couple more minutes. But hopefully that helps you get past a couple common mistakes at least. get going to the back if you finish. Okay, let me share a couple more answers with you on this page at least, and then I'll let you guys ask if there's some of them you want to discuss. So how far does this one go down on this page?
6.
Question 6? Okay. Then this one looks like should be plugged into both. 2 on the left and 4 on the right. So I would say this does not exist. Does not exist for number 5. And then number 6. Okay. So it's good for you to try this one. This is like what we did on the front page, the notes. So you try to just plug this in. You try direct substitution, but when you did that, did you see that it goes to 0 on the top and 0 on the bottom? Okay, so you may not know the process yet, but you should know at least that we've got to do something with this. We have to change the way this looks without changing its size. We need something to cancel, and then direct substitution will work. Well, the only thing that we've looked at so far is factoring. And the numerator doesn't factor and the denominator does not factor. So we're kind of stuck there. So we got to try something else on this one. Anybody have a guess what type of algebra skill? What do you think? Okay, very good. It is going to be multiplying by conjugates. Do you think we should do the conjugate of the numerator or the denominator? Okay, and how do you guess that? All right, the square root is usually a sign that maybe it has something to do with conjugates. So I'll remind you, conjugates mean the same thing, but you change the middle sign. And to make sure that we don't change the question, you have to multiply the top and the bottom by the same thing. So that would get you to that on the numerator. You've got an x minus 2 times the conjugate piece. Now in mathematics, we do use conjugates a little bit more in this course than you need to in other courses, but conjugates usually make things simplify pretty nicely. If you take these two things times these two things, you can FOIL them. So 1 times 1 is 1. You can do the outer part of FOIL and get this. But then when you do the inner part of FOIL, if they're conjugates, they should be exact opposites. So the outer and inner part always adds to 0. And then what about the square root of 3x minus 5 times the square root of 3x minus 5?
3x minus 5.
Okay, just 3x minus 5. But also, here's probably the most likely place to make an arithmetic mistake. This guy was negative, this guy was positive. A positive times a negative is negative. That 3x minus 5, the whole thing is negative, not just the 3x. So this really amounts to 1 plus 5, which would be 6, and a negative 3x. Now, just like on the first page, we did factoring instead of conjugates, different algebra trick, but we needed something to happen before direct substitution worked. What was that thing that always has to happen on these questions? Okay, and unfortunately right now, none of this cancels with this. But if you then factor this, now the x minus 2's cancel, and now direct substitution should be fine. So looks like 2 over -3. So -2/3 is the y value that function approaches as x approaches 2. Now, I'll be honest, I did not expect many people to think to use a conjugate there, and that's perfectly legitimate, especially with summer. Y'all are rusty. Even if you can do it, you may not have thought of it. But now it should be on your radar. So when you flip the page, I bet one of these other questions looks like it might be a conjugate type question. And I guess I lied. There's not one on there. I probably should have put another one on there. But so far, the skills we've seen for 0 over 0 is factoring and conjugates. We'll see a couple other different tricks we can do. But go ahead and keep on going on this back page. We'll make sure we're all on the same page there. And then we'll move on to the other thing we need to talk about today, which is IVT, intermediate value theorem.
Yeah, she has our pass. Just go ahead, though. If it's not
go without a pass, and if someone stops you, just let them know. Someone else has my pass for the counseling. Okay, I'm working these very, very quickly in my head, so there's a good chance I may have some mistakes here. But what did y'all get for question 7? Okay, I agree with -1. So if you need me to, I'll go over that one in just a minute. Somebody different, what did you get for number 8?
2.
Okay, I agree with 2. So if you did not get 2 on number 8, feel free to ask about that one in just a moment. Number 9, somebody different.
-11.
I agree, -11. Hopefully you thought that was the easiest one. So if you didn't get -11 on 9, you definitely need to ask here in just a moment. And then the last, oh, I didn't even work the last one. The next 2 are definitely pretty difficult, so I suspect we need to work on those. Anyone got a guess for number 10? What you got?
-3/4.
Very good, -3/4. Okay, already showed the next one. I got 3. Again, I might have made a mistake because I'm doing a lot of this in my head. I didn't want to write it all out and then have to also rewrite it out again going over it with you. But if you were stuck and or did not get 3. And then the last one should be does not exist. Okay, so let's start with the easier ones and work our way up. Or easier in that everybody thinks different stuff is easier, but the ones that are least likely to miss. Does anyone need me to go over number 12 or 7, 8, or 9? 12, 7, 8, or 9? I do not mind, but okay, I'm assuming most of y'all need to see number 10. Okay, so even though we have not talked about this algebra skill in here, because this is day 2, you should still know the first couple steps and not hesitate on that. Step 1 is what? Direct substitution. You get 0 on the top, 0 on the bottom. So that means what? Okay, we got to make this look different without changing the size. We've got to do some algebra to this. We got to make it look different. Now, this is not one of the more common ones, but it does come up. And this is where I said sometimes calculus can be tough because this is a complex fraction. If you remember how to solve complex fractions, there's nothing special about this question. And if you don't, then you've got to try to remember that on top of the other new stuff. So complex fractions, when you have smaller fractions within a bigger fraction. So to make it not be a complex fraction, you want to multiply everything by its least common denominator. So what I mean by that is I really want to multiply this by 4 to make that smaller denominator go away. But that means everything gets multiplied by 4, every term. And I'd really like to multiply this one by x squared so that those cancel, but it's only equivalent if I multiply everything by x squared. So if you multiply all three of those terms by 4x squared, you're left with 12 minus 3x squared over 4x squared times x minus 2. Now, if you want to try direct substitution, again, you can, but nothing's canceled, so it's probably not ready for direct substitution. We need to do some more work. But that is by far the hardest or least likely step. I know you can all do that, but just thinking to do that can be challenging. So what is one thing I could do to this numerator? Anything. I'm sorry, you said factor. Okay, it's got a GCF. So we could factor out like maybe a -3. Does this factor more?
Yes.
Yeah, switch the terms if it makes it easier to see. X squared minus 4. So this guy fully factored. This is why you always want to practice factoring completely. It looks like this. And now we're in good shape because x minus 2 cancels out x minus 2. Now that something canceled, direct substitution should work out fine. Plug it into what's left over in the numerator, you get -12. Plug it into what's left over in the denominator, you get 16. But that fraction reduces to -3/4. So what I don't think you need to do is go home and practice 20 complex fractions. What you need to get out of this question, and what you might need to circle this question for, is when we get to the test, one of the questions might look like this, and you need to recognize, oh, I got 0 over 0. I have an idea of how to tackle this question. I know how to change it to not be a complex fraction, and then with a little bit of playing around, we can get something to cancel. You're probably not going to do those steps instantly, but as long as you understand the process. Okay, and then one more together, number 11. So you try direct substitution, you get 0 over 0. You have to know unit circle. So if you feel like those unit circle questions on today's mini quiz were hard, then you need to make sure you keep reviewing that. Unit circle does not go away, unfortunately. But you need this to look different. So did anybody have an idea on how to change this appearance a bit?
Oh, the 1 minus sine squared.
Instead of,
Cosine squared.
very good. So we had 3 Pythagorean identities. The main one shows up a lot in calculus. So if you did not take pre-cal last year and you have not learned sine squared plus cosine squared always equals 1, that's something that you need to memorize and recognize. So instead of saying cosine squared, we could say 1 minus sine squared. Those of you that did do pre-cal last year, one of the hardest things we did first semester was trig proofs. We tried to rearrange and make one side look like the other side, and that was really for stuff like this, so that you could brainstorm and have an idea of how to try to change some of that. Now, the top still factors more, because this is a difference of 2 squares. And the bottom factors as well, because it has a GCF. Yes?
The thing that you just did, it's called identities.
This is called Pythagorean identity. It really just comes, I will spare you deriving it, but it really is just a form of a squared plus b squared equals c squared with a touch of unit circle trig in there. So. Okay, and so if you think to factor this, you get something to cancel, and then you should start to be feeling pretty good, because then direct substitution is probably going to work. You're left with 3 times 2 on the top and 2 on the bottom. That reduces to be 3. So same thing. I don't think you need to go home and practice 20 of these. But what you do need to get out of this is sometimes you have to use some trig identities. There's not a million trig identities that show up in calculus, but this is one of them. If you've forgotten about it or you never learned it, you have to memorize it well enough that you can recognize to make this sort of substitution sometimes. Now, I'll be honest, these are on the harder side of some questions, so that's pretty typical. But you need to have a good understanding of the process. Direct substitution, you might be done, you get 0 over 0, you got to try something else, you got to change the way it looks, whether it's factoring or conjugates or complex fraction or trig identity, some way to make it look different so that something cancels, and then direct substitution should work. That's the part that you need to have down. Okay, any immediate questions about that? Anything that jumps out at you that you want to clarify before we jump over? This is a skill that takes quite a bit of practice. Fortunately, when we learn derivatives in a few weeks, at some point we'll come back this year and do something called L'Hopital's rule, and L'Hopital rule gives you an option to work these questions. So you can still work them this way, but some of them you can work a separate way, but you can't do that until you know how to take derivatives. So I can't show you that yet. But that's usually easier on some of them. All right, the other thing we're going to look at today and you might end up having a couple homework questions on this, is something called IVT, intermediate value theorem. We have 3 big theorems in this class: IVT, MVT, and EVT. The other ones don't show up until later. And all of them are pretty straightforward in what they say, but you have to know them pretty well for calculus. So IVT specifically only works if you're talking about continuous functions. What is it? What do we mean by continuous?
Never stops.
Not necessarily.
No breaks.
Right. No breaks, no holes, no asymptotes, nothing like that. So all IVT says, if it's continuous, so we're going to connect point A to point B. If it's continuous, so you can't like pick up your pencil, you can't make a hole in your graph, it's going to hit, and this almost seems like too common sense, but if I have some kind of graph that connects A to B, it has to hit all of these y values at least once, right? If it's continuous from A to B, it's going to hit all of the y values from f of A to f of B. Now, some of those y values may get hit multiple times. Some of them may only hit once, but that's all IVT says, is if it's continuous between some generic numbers A and B, it has to hit all of the y values between A and B. So feel free to connect these 2 points any way you want to, as long as they're continuous. It can be real boring, but it's good for you to see that it has to hit all the y values at least once. Or you can make it really interesting if you want to, but it guarantees that it hits all of these y values at least once. Doesn't tell me anything about these y values, by the way. I don't know for sure that it goes up there unless I see the graph. Okay, so we're going to use IVT to show that this does in fact have a 0, which means y equals 0 somewhere. And then sometimes you're asked to tell where that happens. So between, this is like A and B. So again, I don't know what this graph looks like, and I probably don't have a calculator to graph it like we did above. But if it's continuous between these two, which polynomial functions always are, then it should hit all of the y values from f of A to f of b. So f of a would look like this. Let's see, 2 plus a 16th. And then 2 would be like this. So, does this one, does the IVT guarantee that this function has at least one zero between 1 and 2?
Oh, yeah.
Because it's hitting all of these y values. It hits all of the y values between -4 and 33/16. So it's certainly hitting the y value, y equals 0. Now, sometimes, not always, you have to figure out where that happens. So where does it have a y value of 0? You could set that equal to 0 and solve. Although for this one we would need a calculator, and we won't get into that part today, but I'll go ahead and throw it in for us. If it was just like a quadratic or something, we could do it real quick by hand. But we have a way to get our calculator to solve some of these. It's at about 1.490, which, as you can see, is between 1 and 2. So IVT told me that it was going to happen at least once between 1 and 2. Algebraically, you can figure out, this is what you've been doing since like Algebra 2. Where does it equal 0? Here's where it equals 0. IVT is knowing that it guarantees that it's going to hit a y value of 0 because it has to hit all of these y values. Okay, so same thing on these two. Let's first show that this guy has to have a y value of 11 between 0 and 5. So you want to know the starting y value and the ending y value. This is a polynomial function, so it will be continuous all the time. Sorry, I plugged in the wrong one. Looks like it starts off at a y value of -1, and it goes up to a y value of 29. So if it's continuous, the graph's not jumping around, and it starts off at a y value of -1, and it goes to a y value of 29, does it have to hit a y value of 11? Because 11 is in between those, right? It might hit it once, or it could hit it multiple times. IVT just tells us that it's at least going to hit it once. So, if there's a second part of the question, figure out where it happens, then I just want to know, when does this function have a y value of 11? Quadratic, so set it all on one side, set equal to 0. Very rarely do you need to use quadratic formula, but I guess a few times this year you'll have to, but this one just factors. Now, this particular question, IVT only guaranteed one of those. I really shouldn't have two answers to this. It should be -4 or 3. Any guesses on which one we should keep?
3.
Okay, how do you know that?
Because -4 is not in the range.
Right, because for whatever reason, we were only interested in 0 to 5 on this question. So, -4 also made it happen. It just had nothing to do with this problem. Okay, I want you to try the first step of 3 before I do it for you. So, first we need to see if IVT is going to hold up. This is a polynomial, so it's already continuous. But between 0 and 3, you need to be able to tell me, does it have to have a y value of 0? So, I'm going to freeze my screen while you look at what we did on the last question and try to apply it here. Okay, so does that function ever have a y value of 0 between 0 and 3? Okay, I'm seeing some yeses. I agree, because the starting y value is 8, the ending y value is -1. IBT just says you have to hit all of those y values at least once if this is continuous, and it is continuous. Okay, the second half of the question we just do real quick. It's what y'all are used to. If you needed to know when your function equals 0, set it equal to 0 and solve. That's what you've been doing since Algebra 2. Although we're really only interested in one of these two, you need to pay attention to the domain that the question's interested in. We only cared about 0 to 3. That's the only thing that we checked for, so we should only keep the answer that's between 0 and 3. Even though it also has that y value at 4, 2 is the one we're interested in this question. So again, the idea of IVT is it's almost kind of common sense. If your graph's not jumping around and these 2 points are connected, it has to hit all the y values, but you need to really understand that pretty well. Anything that jumps out at you about these? Okay, then let's shift gears here. I want to try to get you to have very little homework, if any. So on a scratch piece of paper, go ahead and number it as number 8. On your Chromebooks, I assigned 2 Khan Academy quizzes to you guys. They're called quizzes, but they're like 4 questions. One of them is testing to see if you know if you can use IVT. Like, is it continuous? Are they stating enough information? And one of it's using them. I don't care which order you do those 2 in. But we do quite a bit of Khan Academy first semester because Khan Academy does a good job of just practicing skills. Just can you do it? Can you recognize what you need to be doing? And on these, you can try them as many times as you want to. So you pick whichever one of those 2 that I assigned to you. If you get 4 questions in a row correct, then you got 100 on that one, and great, you're done. If you make a couple mistakes, try to figure out what mistakes you made. I think you can click like get more help, and it will show you like step by step, and you can compare what you didn't think about or where you went wrong. And then you can try it again. So I do want you to get to 100% on both of those. So if you can do those in 1 try, that's great. And if you need 50 tries, then if that's what it takes, then that's what you need. And you'll have about 17 minutes, but those are going to be due before class starts on Friday. So if you don't 100% one or both of those, you can keep trying for homework. But start of class Friday, I put the grade in, and then you're stuck with it. So you already started, right? I think you already did some of them. Okay, if you can't, just log into Khan Academy and it should show you the 2 that are assigned. And they're multiple choice, so. Also, I'm a pretty big fan of Khan Academy first semester because, again, I try not to give y'all too much busy work. Some of y'all need to practice a ton of these, and some of you can do it on your first go. And Khan Academy is just a good balance there. Because if you really know it, you should be able to get 4 in a row right within a try or 2. And if there's some misconception you have, you're going to be missing some of them until you get help. But when you miss one, again, please click the Get Help so you can learn from your mistake before you just press on. If you don't learn from your mistake, you're just going to keep making the same mistakes. Well, it was confusing.
What was asking?
It's pretty wordy.
Yeah, but I got it. comes up with the first
And again, there's like no pressure on these. Y'all don't have to like spend 10 minutes thinking about each one. Make a good educated guess. If you miss it, it's not a big deal. You can retry it as many times as you want to. But you do have to get whatever 4 in a row right to get that score. I think once you miss one too, it might give you a chance to just start over. I think that may fix that. And then from up here, I can see which ones y'all are missing, so I can see if there is a certain question that multiple people are missing, if it's something I need to clear up. Did y'all get that okay?
Yes.
Do you know how to get to the class recordings on the top of our website? I had you bookmark the website last class. At the top of that, it'll have like a calendar. And later on today, there'll be a link there, and you can watch what we did here. So you can go on the class. Honestly, I don't know that you actually even really need scratch paper on these kind of academies, but if you do, put it on that. So from 0 to 2, the y value goes from -2 to 3. Right, so doesn't it have to put a y value of -1 here? From 0 to 2? From 0 to 2, if it's y values of -2 to 3, then that guarantee that you put a y value of -1 in, because that's in between those. So yeah, that's why you have to do that. Why did it? This is go to. Oh, you went to .org. Go to khanacademy.com. And then if you do your school login, it should just pop them up. You don't see it now. Again, I have no preference on which one of the two you do, so feel free to do whichever one sounds easiest first. We go all the way to 5, right here. So I don't have it linked right now, but later on today, there'll be a link right here for calculus, and that'll be the class recording, so you can listen to what you missed. Also, sometimes not a bad idea if it gives you like a table with 3 or 4 points on your paper, you could just quickly plot those points and connect them, and then sometimes that little bit of a visual helps you see and answer what they're asking a little bit easier.
Do you have classes after this? Okay. Good.
And I have bus duty or car pickup duties after, so. 4 o'clock.
How's it going? Anything I can help with yet? Can, but there's no movement for the first couple weeks, so. I think the first 2 weeks, and then they'll open it up.
Yeah, that's
So
what
it'll be
I
like
want.
last year, Tuesday through Friday.
Make it.
I have a specific question.
Okay.
So,
Yep. Why is
this
that?
was the equals to 3 because this parentheses became 2 like
Right here, when I factored this is the difference of 2 squares. But, so we've got 1 being squared here, so I put a 1 and a 1. And what's being squared here is the sine, so this should just be sine and this should be sine. We did sine squared.
Oh.
That should just be 1 plus sine and 1 minus sine.
Okay, so this is just sine and then
Okay.
and so that would make it sine.
Which is 1 plus 1 is 2, which cancels out with that 2.
And so then you go to the -1 and 2. And
When you plug this back into what's left over, the sine of pi over 2 is 1.
Okay.
3 times 1 plus 1 divided by 2 also
No,
implies
that makes
3.
sense. Like, why sine?
What sines the y value?
Right.
That's the point there on the unit circle.
Oh, it's 1 point here. This one is, oh, 0 point.
But the y value is 1. That's why the sine of pi over 2 is 1.
Okay, I understand. Get back to the easy bit. Oh, I guess it's. I don't know. Mr. Townsend, could you explain this to me, please? So, I put in main, this one first because it related to this two, and then this one is two, so
Okay, but 2 different things. This is talking about x values,
Uh-huh.
when it occurs. This is a y value, what the function is
Okay.
equal to.
Okay.
So from, it looks like they're wanting you to look x values of 1 to 5, which is how it's one of these 2.
Uh-huh.
And it's hitting y values between 1 and -3.
Uh-huh.
2 is outside of that, but -2 is not outside of that.
Okay, so this number is gonna be between these two numbers, and then it's gonna be between 1 and 5, right? Because that's what's asking.
Right, so let me put this on
Okay,
the
that
board
makes
real quick.
sense.
Here's what I meant by it. This might help later on. One of them is 1, 1, and the other one is what?
For what?
What is it?
Oh, it was 1, 1, and, I passed it, but I think it was like -5 and 3 or something.
Okay, so So if you force yourself to plot these 2 points, you can see that between -5 and 1, there has to be, it has to hit all of these y values. So
Okay.
one of those answers had 2 as a possibility,
Oh, okay.
and one of them had an answer that was like down here. So
Okay.
it might hit down here, but IVT doesn't guarantee that.
Okay.
It just guarantees that it has to hit all the y values between those.
Okay, thank you.
You guys have about 4 minutes here. So again, your homework here is to stick with those 2 Khan Academies. If you miss one and you keep missing them, please click the Get Help so you can see why you're missing it and not have to do it more times than necessary. But ideally, you should have 100 on both of those, and that will go in as a homework grade. So if you get a 50 on both, then you're going to get a 50 on the homework grade. So you really should get 100 on it because you need to know it anyway. And again, that is due, should say in Khan Academy, but it's due before class starts on Friday. So anytime between now and then.